In this class, let's discuss on HCF, which stands for highest common factor. This is also called as greatest common factor. So we will be referring in this class as greatest common factor. And LCM, which is called as least common multiple. So we will cover these two topics in this class. And before going into these topics, I just want to explain about a few concepts which would lay foundation for these LCM and GCF. So if you understand those concepts, mostly you can easily grasp the LCM and GCF part. So to start with, let's see what is a factor. A factor is a number. A factor of a number is like you can divide the number with a factor with remainder 0. That means a factor can divide the number equally. So let us see for 6, number 6 example. Let's see if let's list the number of let's see all the factors for 6. So maybe we have studied earlier that the fact families and other stuff, right? So I can start writing as 1 times 6 is equal to 6, 2 times 3 is equal to 6. These are the two different fact families, and each member of the fact family actually can be like a factor for this number. So 1 comma 2 comma 3 comma 6, these are all factors of 6. You take any number from this list. 3 3 can divide 6. So when 6 is divided by 3, the answer is 2 and the remainder is 0. So the factors can divide the numbers. Then what is a multiple? So multiple is a number which is obtained when you are multiplying a number with another number. Say for example, if I see if I want to know the multiples of 6 are like 6 times 1 6, 6 times 2 12. Like you can multiply that number with any number available in the natural numbers. So that list of multiples will be like unlimited, while the factors are limited, and the list of factors is known to us, but like the list of multiples will be unlimited. So in this case, if you see, the multiples of 6 are 6 comma 12 comma 18. So this is a factor and this is a multiple. Okay, let's see um, what we have studied. So the factors of 6 is equal to 1 comma 2 comma 3 comma 6. Multiples of 6 are 6 comma 12 comma 18 comma 24. So if you see here clearly, a factor of a number is something that using which you can divide the number. That's clear, right? And multiple, this number can divide any multiple with remainder 0. That is simple, right? The factor can divide the number, and here the number can divide the multiple. That is a concept here. So after understanding this concept of factors and multiples, let's understand one more concept that's called prime factor. As the name specifies, it is a factor. It is a factor, and there's two concepts here. It's a factor, and as well the factor should be a prime number. So prime factor of a number is a factor through that number as well. The number should be a prime number. For example, we have studied the factors of 6, right? Factors of 6 is equal to 1 comma 2 comma 3 comma 6. These are all the factors of 6. And in this list, if I wanted to know what are all the prime factors, what are the prime factors of 6? So we know 1 is not a prime number, this is not a prime factor, and 6 is not a prime number as well. So this is not a prime factor. So the prime factors of 6 are 2 comma 3. So we have studied what is a factor, and then we moved on to understand what is a prime factor. So factor is a number that can divide the, using factor you can divide the number, right? And prime factor of a number is the factor of a number which is also a prime. That's clear, right? So after this, one important thing before we understand the GCF and LCM. So there is one method, prime factorization. This is extensively used whenever you are dealing with LCF and so LCM and GCF. So let's understand this process, prime factorization, and then we will just see how we can find the LCM and GCF of the numbers. So what the prime factorization says is a number, any number can be broken down into, a product of prime factors. So it is just like prime factorization is nothing but product of prime factors, which is equal to that number, right? So to understand this prime factorization, I went on to explain the factors and prime factors for you first. So any number given to you, if I ask you to write the prime factorization of the number, you should just give me the multiplication of the prime factors of that number, where the answer will become 18. Let's take an example and see how we can write the prime factorization of 18. Let's see the prime factorization of 18. So what are the factors of 18? Let's see what are the factors of 18. Factors of 18 is equal to 2 comma, it will start with 1 comma 18, 2 comma 9, 3 comma 6, and after that it again repeats itself, right? So let me list all the factors: 1 comma 2 comma 3 comma 6 comma 9 comma 18. So now factors of 18 are known. What are the prime factors of 18? Prime factors is equal to, we know that 1 is not a prime, and 6 is not a prime, and 9 is well not a prime, because 3 times 3 is 9, and 18 is itself again 18 is also not prime, because like it is 3 times, sorry, 2 times 9. So the prime factors is 2 comma 3. So as the prime factorization specifies, the 18 should be represented as the product of the prime factors. So how can I represent 18 as the product of prime factors? 18 is equal to 2 times 3, it makes 6, and 6 times 3, 2 times 3 is 6, and after 6, right, you choose any of this factor such that the multiplication should be equal to 18. Now 2 times 3 is 6, 6 times 3 is equal to 18. So this is the prime factorization of 18. Hope this is clear, right? Let us take another example and see the prime factorization. So let me see, for 24 we have to derive the prime factorization of 24. Let us see the factors of 24 first. So to get the factors of 24, we have to go with the fact families. 1 times 24 is equal to 24, 2 times 12 is equal to 24, 3, yeah, 3 times 8 is equal to 24, again, sorry, yeah, 4 times 6 is equal to 24, again after that it is 6 times 4, it is a repetition of the earlier things. So now the factors are like each member in this fact family is like a factor to it. So if I list down 1 comma 2 comma 3 comma 4, 6 comma 8 comma 12 comma 24, these are all the factors of 24. Now let's see the prime factors. 1 is not a prime, 2 is a prime, 3 is a prime, 4 is not a prime, 6 is not a prime, 8 is not a prime, 12 is not a prime, 24 is not a prime. So only it has the prime factors 2 comma 3. Now I need to represent the 24 as the multiplication of these prime factors. So 24 is equal to 2 comma 2 times 3 is equal to 6, and 6, and the remaining I have to select the factors from here so that I should reach to 24, right? 6 times 6 times 3, 18. There's no way that I can reach to 24, right? I will be selecting the 2. 2 2 times 3 is 6, 6 times 2 is 12, 12 times 2 is equal to 24. This is the method that you should follow to generate the prime factorization method for any number. So but when you are selecting very large numbers, so the prime factorization uh, using this approach might be little difficult, because like you have to list down all the factors. Say for example, here itself we have got 8 factors. Say for example, if the factor count is increases to 100, 200, then listing all the factors and selecting the prime factors and prime factorization is like a tedious process, right? So there is an alternative approach which you can use to get the prime factorization method. So for example, now in this case, the approach is, it is simple. So just take all the prime numbers from 2 to, and just make a list of all the prime numbers, 2 comma 3 comma 5 comma 7, and which is less than the given number. Suppose let me take till 11. Now from 24 you start selecting the smallest prime number and see if the prime number can divide this 24 or not. So now if I select 2, we know that 24 can be divided by 2. So the answer is 12, and keep repeating the process until this prime 2 is, and you cannot divide that number with 2. Still 2 divides 12. I will again divide it with 2. Then again I will divide it with 3. So now the number 2 cannot divide 3. Then just move on to the next number and start dividing with that number until you get the answer as 1 here, until you get 1 in the bottom. Now these are all, if you see all the values that you use to divide 24 to reach 1, these are all the prime factors of the number. Though it is repeated, it's the prime factor. 2 is a prime factor to 24, 3 is a prime factor to 24, right? And you see the 2 is used 3 times to divide 24. Now if you represent all these numbers with the multiplication sign in between, this is the prime factorization of the 24. So if you see, if you compare this method, the value from this method to the earlier one, whatever you have achieved, the both are equal. If you see, 2 is used 3 times here, and 2 is used 3 times, and 3 is used once. So this is the way that you should use to get the prime factorization method. So these are all the foundation concepts that are needed for understanding LCM and GCF, greatest common factor. So let us just recap whatever we discussed till now. We started understanding the concept of factors and multiples, factors and multiples, and then we went on to discuss with the prime factors, and finally we concluded with the prime factorization of a number. Now let us take the GCF, greatest common factor. So as the name specifies here, it is actually asking us to get the factor. So anytime, like one common point I wanted to say, whenever they ask the greatest common factor, they are asking to get the greatest common factor for more than two numbers. A single number cannot have a greatest common factor or least common multiple. You are seeing the term here common, right? Common means you are finding it for more than two numbers. It could be two, three, four, any set of numbers. For those numbers you are trying to find the greatest common factor. Now the name specifies here, if you clearly observe the names here, it will give you most of the answers for you. So let me right. So now if you see, they're asking, say for we are given two numbers, number one and number two, and we are asking, like it is being asked to find the common factor and which is greatest for these things. So number one can have some factors, fact 1, fact 2 kind of thing, and number 2 also can have some factors, and you have to find a common factor from these two numbers, some common factor from these two numbers, and the GCF says you have to select the greatest common factor from these numbers, right? Yeah, we have to select the greatest common factor from these numbers. Let's take a small example and just go step by step manner and to find the greatest common factor. So find GCF of 12 comma 18. Right, what we discussed earlier, this is dealing with the factors, and we have to find the common factor for both, and then we have to select the greatest common factor. Let us just drive this question in the similar lines. Now let us see what are the factors of 12. So the factors of 12 are 1 times 12, 2 times 6, 3 times 4, right, is equal to 1 comma 2 comma 3 comma 4 comma 6 comma 12. Then what are the factors of 18? Let us do the same exercise. 1 comma 18, 2 comma 9, 3 comma 6. I think we are done. So it will be like 1 comma 2 comma 3 comma 6 comma 9 comma 18. So the final part, we have just got all the factors of 12 and 18. So this is in GCF we have evaluated factor. The next one is finding the common factors for these two numbers. Common factors is equal to, what are the common factors here? 1 is a common factor, 1, 2 is a common factor, 2, 3 is a common factor, 3, and 4 is not a common factor, and 6 is the common factor. And you have 12 here, and you have 9 and 18, so they are not common. So common factors for 12 and 18 are 1 comma 2 comma 3 comma 6. And this is interesting, right? Now you got all the common factors. The next step is this common factors is also done, and we have to choose the greatest among these common factors. What is the largest number in these common factors? It is 6. So the GCF of 12 comma 18 is equal to 6. This is the process you should follow to find the greatest common factor. First you have to get the factors of the each number. Maybe I'm in this problem I gave you just two numbers. Maybe you could be asked to get the GCF of 4 or 5 numbers. So for each number we have to list down the factors, and that is the first step. And from those factors we have to choose the common factor, and in the finally we have to choose the greatest among the common factors. That is your answer for the GCF. But like if you see here, these are the two small numbers 12 and 18, and we were asked just, and these are just two numbers. If if uh, if there is a problem to find GCF for more than four numbers, and the numbers are like 4 digit and 5 digit, then if you start listing the factors and just going start listing the factors and then finding the common factors, that would be again a tedious method. And that's the reason, and mathematicians have evolved with the two different methods. There are two different methods to find GCF of any given numbers. Let us understand those two methods, and we then once we understand those methods, we will do couple of problems so that it will be like in future if anytime we are given with the GCF problems, it will be easy to solve. So the first method is prime factorization, and the second method is division method. So when I'm explaining the two methods, I will take the same set of numbers so that it will be easy for us to compare the answers and other stuff. So let's find the GCF of 24 comma 36 in both scenarios. So out of these two, again division method is the simplest method. I will start with the division method. What the division method says is always choose the biggest number. The biggest number will be the dividend, and you have to divide 36 with the next smallest number. In this case, there are only two numbers. I have taken the 36 as the dividend, and 24 is the smallest number. Now, if you divide 24 with 36 with 24, the answer 24 goes one time, and the remainder is 12. Now, in this case, the 12 becomes the new divisor, and you have to divide 12 using 24. Sorry, you have to divide 24 using 12. So 12 goes two times, and the remainder is 0. And we have to continue this process until you get the remainder as 0. Until the remainder is 0. Always, if in this instead of 0, if you would have got a different number, then that new number would be the divisor, and the 12 becomes the dividend. And that process continues until you get the remainder as 0. Now, the GCF is the last number that you used as the divisor. In this example, I have used 12 as the last number to divide 24, right? This 12 becomes the GCF. So this is the simple example. This is the method. I will just give the steps once again. Given any set of numbers, say for example two numbers, and now the largest number will become the dividend, and the 24 will become the divisor. And using 24, you have to divide 36. Now 24 goes one time, and the remainder is 12. And now the new remainder, anytime the new remainder will become the divisor, and the previous divisor will become the dividend, and continue that process continue this process. Selection of the remainder becomes the new division and the previous division becomes the new dividend. Continue that process until you get the remainder as 0. And once the remainder is 0, the last divisor that you used is the GCF of the two numbers. In this case, we have just taken two numbers, right? Say for example, if I give you three numbers, what you should do now, for the first two numbers you found the GCF as the 12. Now you have to repeat the division process for this 12 and the another new number. Now you have to find this GCF is for 12, 24 and 36, right? So even if you add any other number, the GCF for these two numbers will not change. So you can take this GCF of these two numbers 12, and if you find the GCF for 12 and 34, you would get the GCF for the three numbers. For example, four numbers are there. Find the GCF for these two numbers and it will be 12, and find the GCF for these two numbers, you will get a new GCF, and find the GCF for these for the new two GCFs, you will get the GCF of all the four numbers. That is the technique that you should follow to get the GCF. So this method, division method, as we see, it is good. It is easier if you have two numbers, and like if you have more than two numbers, you have to continue this process again and again. So like when you have just two numbers or three numbers, just use the division method. And if you are given with multiple numbers like four numbers or five numbers to find the GCF and that stuff, then a division method is not advisable. Just use the prime factorization method. So as per the prime factorization, what we should follow is we have to generate the prime factorization of each number. So prime factorization of each number you have to get it. That's the reason why I covered the prime factorization at the very beginning of this chapter. So what the prime factorization means is it's breaking down the number into the multiplication of or the product of prime factors. And we have also seen the method, right, to generate the prime factorization. Now let us see how we can do the prime factorization. So as we discussed earlier, we have to choose the least prime number and start dividing until you get the final value as 1. So the 2 goes into 24, the 12, and again 2 goes, it is 6, again 2 goes, it's 3. So the prime factorization of 24 is 2 times 2 times 2 times 3. If you start multiplying one with one factor with another, and after multiplying all the factors, this would equal to 24. Now if you see, 3 times 2 is 6, 6 times 2 is 4, so 6 times 2 is 12, 12 times 2 is 24. This is equal. Similarly, find the prime factorization for 36. So 2 times 18 is 36, 2 times 9 is 36, and 3 times 3 is 9. So the prime factorization for 36 is equal to 2 times 2 times 3 times 3. So now if you see, 3 times 3 is 9, 9 times 2 is 18, 18 times 2 is 36. This is equal to the number 36. So this, until this point we are sure, right, how to get the prime factorization for 24 and 36. We have done it. And now the trick from here is to get the GCF. Let us see, for each of the factor, say for each of the prime factor in this prime factorization, let us see the number of its occurrences. So what are the distinct prime factors in this prime factorization? You have 2 and 3 here, right? And you have 2 and 3. How many 2's are there here? It is 3. And how many 3's? It is 1. And how many 2's? 2 and 2, right? 2 is occurring 3 times in this prime factorization, and 3 is occurring 1 time. Similarly, in the prime factorization of 36, 2 is occurring 2 times and 3 is occurring 2 times. Now whenever you are finding the GCF, you have to choose the least number of occurrences of the factor. in both the things when you compare. So 2 is occurring 3 times here and 2 is occurring 2 times. What is the least number of occurrences? It is 2 times. 2 occur 2 times. So you just place 2 times 2. The next one is, the next factor is 3. 3 occurred 1 time here and 3 occurred 2 times here. What is the minimum number of occurrences? It is 3, right? So always we have to choose the least number of occurring factor in this case. So now the GCF is equal to 2 times 2, 4, 4 times 3 is 12. See the GCF from prime factorization method and GCF from the division method, they both are equal. They both are equal. And I think it's clear, right? So the GCF is the greatest common factor, and there are two different methods to find the GCF of the given set of numbers. So we discussed about division method. The division method is you can use the division method when you need to find the GCF for two or three numbers. That's easier to follow this approach. And prime factorization, when you are given a set of six or seven, more than three numbers, then the division method may not be friendly. You have to use the prime factorization method. So I think we're good with the GCF, right? Let's move on to LCM. So LCM, now if you see the LCM is abbreviated for least common multiple. So in the beginning of this chapter we have discussed about the multiples, right? Multiples are the numbers uh, which are uh, which are divisible by the given number, right? So now let us see let us see how to find least common multiple of um, least common multiple when you are given more than two numbers, right? Similarly, how we have done with the GCF, we will do the traditional method of finding the LCM, and then we will just move on to understand if there are any easy methods for getting the LCM. So as the definition for LCM, as the LCM is abbreviated for least common multiple, so this talks about multiple given two numbers. Let's take 2 and 3. We need to find the LCM for 2 and 3. So let us just in the GCF we went on finding the factors, right? Here let's start finding the multiples. The multiples of 2 are 2 comma 4 comma 6, 8, 10, 12, 14, 16, 18, 20, and the list goes on. And the LCM, the multiples for 3 are 3 comma 6 comma 9, 3 times 3 9, 3 times 4 12, 15, 18, 21. So this is bigger. So this list again goes on. Now let us see the common multiples for 2 and 3. In the first list we have the multiples of 2. In the second list we have the multiples of 3. Now let's find the common multiples of, in the case of GCF you found the common factors, right? Here you are finding the common multiples of 2 and 3. So is it 2 common multiple for 2 and 3? No. 4? No. In this case 3? No. So you see here 6 is the common multiple for 2 and 3. 6, and then again you come, it is 12. Then again next one you see 18. So these are all the common multiples for 2 and 3. And now if you see what the LCM says? It is the least common multiple. In all the common multiples, the least number is chosen as the LCM. So the LCM in this case is equal to the least number in the common multiples, which is 6, right? So this is the traditional method to find the LCM for any given two numbers, more than two numbers. So what we do, just we start listing down all the multiples and then selecting the common multiple, and then selecting the least common multiple, least number from all the common multiples. So this is the method. Again, as I said earlier, this traditional method might not be friendly because like it takes a lot of time and tedious efforts to find the common multiple, least common multiple when you are given with bigger number or a large set of numbers. So in this case, again, we have two different methods. The names of these methods are similar to GCF, but the way you should do is little different. So we will use the prime factorization method, and the division method. So let's take an example of 12 comma 18 comma 24. Let's find LCM of 12 comma 18 comma 24 using both prime factorization and division method. So earlier we saw how to get the prime factorization for a number, right? Let us get the prime factorization for this 12 comma 18 comma 24. 2 times 6 is 12, 2 times 3 is 6, and 3. So you reached 1 and we stop it. Let's continue the next number. 2 times 9 is 18, 3 times 3 is 9, 3 times 1 is 3. 24, let's start with 2. 2 times 12 is 2 times 12 is 24, 2 times 6 12, 2 times 3 is 6, 3 is 1. So you have reached all the cases 1, right? So the prime factorization for 12 is 2 comma 2 comma sorry 2 times 2 times 3. In this case 2 times 3 times 3. In this case it is 2 times 2 times 2 times 3. So now in the GCF you have selected the least number of occurrences for the factor, right? So here we have to choose the maximum number of occurrences. So the maximum number of occurrences, if you choose, then you would get the LCM of the numbers. So in this case 2 occurred 2 times, in this case 2 occurred 1 time, in this case 2 occurred 3 times. Now you have to choose the maximum number of occurrences. Now the maximum number of occurrences is 2 times 2 times 2, right? And then for 3 it is only 1 here, it is 2 times here, and it's 1 time here. So the maximum number of occurrences is 2 times. So now we have to take those 2 and place it here. The LCM is 2 times 2 times 2, 3 times 3. Just multiply all these prime factors, you would get the LCM for 12 comma 18 comma 24. Now if I multiply 2 times 2 4, 4 times 2 8, 8 times 3 is 24, 24 times 3 is 72, right? Let's do the division method here. The division method here is little different. So what you have to do is you have to just write down all the numbers comma separated and start dividing with the least. It is similar to that of prime factorization, and start dividing with the least prime factor. And if you and divide that, select a prime factor that can easily divide and that can divide more than one number. So now in this case I select 2. 2 can divide 12 18 24, right? So I selected 2. So when 2 is divide, when I'm using 2 to divide all the numbers, I get 6 for 12, 9 for 18, and 2 24 12. So now again, if more than one number can be divided with 2, I can use that number. So 2 can divide 6 and 12, right? I will take 2 to divide. Now 2 times 3, 6. And it doesn't divide, so I will not divide that number. And 2 times 6 is 12. Now in this case, next one is, if the number is divides, if the number divides, if the prime factor divides the number, and just write the quotient. Otherwise, just write this number as it is. In this case, the 9 was not divided by 2, and we just wrote down the 9. Now let's divide with 3. 3 times 1 is 3. 3 times 3 is 9. 3 times 2 is 6. Now you see, it's all like you cannot divide with any of the numbers. Now just start multiplying each of the factors present here. So 2 times 2 times 3 times 3 times 2. This is the LCM. So let us compare the LCM value from these two methods. So in this prime factorization, the 2 was present 3 times. In the division method also, 1, 2, 3. That was equal. And the 3 is present 3, 1, 2 and 2 times. So the LCM, though you did it using the prime factorization or division method, they both are equal. Right? So the answer would be equal to 72. Either method you can follow to get the answer. So but if you see clearly, the division method looks to be little easier, right? It is so fast to calculate the LCM. In the case of GCF, the prime factorization was helpful. The division method was little tedious. So but like based on your practice and your expertise, you can choose any method to um, derive the GCF or LCM. Now let us see the final point I wanted to cover is there any relation between GCF and LCM? LCM. Is there any relation if present between these two things? Because like if you see here, both are using the prime factorization method. It's just like taking the prime factors, and in the GCF case you selected the least number of factors. In the LCM case you selected the highest number of factors. It's all the factors and multiplication thing, right? Let us see if there is any relation between these two numbers. So just take an example of 12 comma 8. This first number is 12 and the second number is 18. Let us compute LCM for 12 comma 8, and let's compute GCF for 12 comma 8. So I'll take the division method for LCM. So division method starts 12 comma 18, and now if I see, I can divide with 2. 2 times 6 is 12. 2 times 9 is 12. Now I divide with 3. 2 comma 3. So there is no common factor that can divide these two things. So the LCM is equal to 2 times 3 times 2 times 3, which is equal to 6 times 6, 36. I will, because there are two numbers, I will use the division method for GCF as well. So from 12 and 18, the biggest number is 18. 18 goes as the dividend, and I will divide with 12. 12 times 1 is 12, and the remainder is 6. Now the remainder becomes the new divisor, and 12 becomes the dividend, and 6 goes into 12 two times, so the remainder is 0. When the remainder is 0, I will stop the division process, and the last divisor value becomes my GCF. So the GCF is 6 and the LCM is 36. I will show you the interesting relationship between the GCF and LCM. If you multiply LCM times the GCF, what value you get? It is 36 times 6, right? 6 times 6 is 36. 6 times 8, 6 times 3 is 18. 18 plus 3 is 216. So the multiplication value for LCF and GCM is 216. And let us divide the two given numbers, 12 times 18. 18 times 2 is 36. 18 times 1, 18 plus 3 is 216. If you observe clearly, the multiplication value for the given two numbers is 216, which is equal to the multiplied value of LCM and GCF. That is the relationship between the LCF and LCM and GCF. So if I write it down, LCM times GCF is equal to number 1 comma number 2. This is the interesting relation between LCM and GCF. So sometimes there might be sometimes we know the GCF and we know the two numbers, and maybe we can quickly calculate LCM just multiplying the two numbers divided by the GCF. That will be the easiest method. So this is the relation. The multiplied value of LCM and GCF will be equal to the multiplied value of the multiplication of those two numbers. So let's do a recap of everything whatever we discussed in this class. We started with the understanding of factors and multiples, and then we went on to understand the prime factors and prime factorization. Then we explored what the traditional methods for LCM and GCF, and then we discussed the better available methods for both finding both GCF and LCM. And finally, we concluded just taking an example, the relationship between the LCF and GCM, and that is just like the multiplication of LCM and GCF is equal to the multiplication of any given two numbers.